Protecting against cross-site scripting attacks. Session learning outcome. After finishing the session, you should be able to first explain what is a cross-domain security in a web application attack, concept, methodology, and techniques. Performing different type of cross-site scripting attacks, describing methods to protect against cross-site scripting attack, and of course, lastly, practicing input validation for secure programming. Cross-site scripting attack, or as we call it, XSS. Uh, as an example, an attacker injects some malicious client-side code. When I say client-side code, I mean JavaScript code because we know that the JavaScript work in a client side, in a web page provided by a legitimate server. Such a malicious code is then executed by the victim client to hijack user session, deface website, insert hostile content, redirect users, hijack the user's browser using the malware, and etc. It's not only this, and we have a lot of more. For now, it would be all of these. Cross-site scripting is a particularly dangerous because the client browser trusts the honest server, so it could be configured the execute script sent by the server without any protection. And of course, attacker can do operation. For example, one of the small examples would be money transfer on behalf of the victim user or the session hijacking. Now, cross-site scripting uh, being explained in this graphic. First, the hacker injected trusted website with a malicious script. We have a distrusted website. It works legitimately. It has no problem. A hacker comes and it will put a malicious script inside it, or a script, a small code that will do malicious things inside this website. Now, me as a victim, I will go to that website and I will do my day-to-day job or searching for something. I will be the victim of this type of attack because already the hacker put something inside it. And of course, victim browser, which is me, execute a malicious script unknowingly for a desired information, session token, key, etc. By another word, this hacker will put the script inside this website. This website has problems, but it is legitimate. Once I will go, or me or any other one go to this website, in behind the scene, but in the background, this website will run the attacker's script, and then it will return back some of the codes or some sessions and cookies, for example, to the hacker. Now, OSAP describes cross-site scripting as follows. OSAP is Open Worldwide Application Security Project. Cross-site scripting attacks are type of injection in which malicious scripts are injected into otherwise benign and trusted website. So this hacker will put something in this trusted website. XSS attack occur when an attacker uses a web application to send malicious code, generally in the form of a browser side script to a different end user. So now when this user or this victim will go to that website, that part of the code that this hacker sends, it would be sent to the laptop of the victim, and the laptop would be infected by it. Cross-site scripting is the most prevalent and pernicious web application security issues. Client-side programming languages such as JavaScript, HTML, VBScript, and Flash, and etc. And by the way, HTML is not a programming language; it's a, uh, markup language. Now we have OSAP XSS, and we have a Java injection, and C++, Python, PHP, JS, and TS. Broken authentication, Java, CS, C++, C Sharp, Python, and all the way. These are the hotspot and vulnerability. For example, Java have the hotspot and vulnerability in injection, which is A1, and so on, all the way to TS, which doesn't have the vulnerability part. Now, XSS impact has a significant impact, like, or if I've been infected by XSS injection, these are the impacts on me. Stealing session cookies, creating false requests, creating false fields on the page to collect credentials, redirecting your page to a non-friendly site, redirecting your page to creating a request that masquerade as a valid user, stealing confidential information, execution of a malicious code on an end user system, active scripting, insertion of a hostile and inappropriate content. Quick example would be from the browser address bar, Chrome or Firefox, access attack, and validity to phishing attack. We have javascript.alert, XSS test, or javascript.alert document.cookie. Now, most common location for XSS injection. It would be search fields because we can insert something to that website, input field like a user password or search or maybe comment section or any other input, error message that return user supplied text, hidden field that contain user supplied data. For example, there are some parts that I have hidden from the eyes. Any page that display user supplied data, message boards, freeform comments, and HTTP headers. Now, how does XSS work? Cross-site scripting works by manipulating a vulnerable website so that it returns malicious JavaScript to users. When the malicious code executes inside the victim's browser, the attacker can fully compromise their interaction with the application. Cross-site scripting XSS continued. XSS attack occur when the attacker uses a web application to send a malicious code, generally in the form of browser-side script to a different end user. Now we have this attacker. First follow the link goodserver.com-cc and malicious code. So you see this part has no problem. However, the other part will have some malicious code. HTTP request goodserver.com malicious code will be sent to the server and the web server web page containing the malicious code. We have server and a client-side XSS. Untrusted user supply data, the server side, of course, the server XSS. Untrusted user supply data is included in a HTTP response generated by the server. However, it is different from the client XSS. In the client XSS, untrusted user supply data is used to update the DOM with an unsafe JavaScript code. Or by another word, in the client one, we already have everything, but the attacker will send something that would update our safe JavaScript and it will change it to some malicious or unsafe JavaScript code. Client-side script interact with the document via the document object model, DOM. Script can read or modify the content of a paragraph or of a text within the document or even completely change the appearance of the page or alter the appearance of the page. Script can interact with the browser DOM even although script can receive and react to user originated events such as mouse clicks or key presses and also create and dispatch event and for example simulate a mouse click on a button HTML document. Now document object model DOM. The W3S document object model is a platform and a language neutral interface that allow program and script to dynamically access and update content, structure and style document. So having DOM, it will uh, allow us to dynamically access and update the content, structure, and style of a document. So dynamically access the document, dynamically update the document, okay, and the content and the structure. When a web page is loaded, the browser creates an HTML DOM of the page with the object model. JavaScript get all the power needs to create the dynamic HTML. Change JavaScript can do this. Change all the HTML element in the page. Change all the HTML attribute in the page. Change all the CSS style in the page. Remove existing HTML element and attribute. So basically, it can do nearly everything inside our document. Changing HTML element, changing the attribute of a HTML page, changing style, change existing element attribute, add new HTML, or by another way, having to do everything. The same origin policy is the same as a sometime also referred to as a cross-domain security policy. So if they ask you in exam, cross-domain security policy will also be called same origin policy, cross-domain security, or same origin policy. Script can only access properties, including cookie and DOM object and their attribute associated with the document from the same origin. The origin of a document is defined by the scheme, also referred as a protocol, for example, HTTP or FTP, hostname, and a port document URL. However, the URL path is not considered a part of origin. Now, what does this mean? It means that, for example, you have a web browser. This, let's say, is a Chrome. Inside it, you have opened, let's say, your bank, and you opened some other tabs too. For example, this one is evil.com. Now, this evil.com have some codes that might be harmful for the bank. For example, from this tab, it can open this tab. However, the proper isolation will what will be the proper isolation between these tabs will provide it for us. It would be that it will create a sandbox for this and a sandbox for this one. Now, this one cannot access this one, and also this one cannot access this one. So basically, there would be no connection between these two tabs, so nothing will happen. Exercise. Now, we have these exercise. Assume that the malicious website called the following code into the page. Which of the following code belong to the same origin policy? Now we have a href http my www.service.com, some URL, click here. Now iframe style display none, http www.mywwservice.com, some URL iframe. Now, however, this one says script source would be my www.service.com, some URL.script. Now I will put this exercise for you, and it would be to know if, for example, this and this are in the same origin, and this, for example, are the same origin or not. We have types of XSS. We have a non-persistent or reflected, we have stored or persistent, and we have a DOM-based, document object model-based. Non-persistent malicious content from a user request is displayed to a user in a web browser. Malicious content is written into the page after from a server response. Social engineering is required, runs with the browser privilege inherited from the user in the browser. How about the stored or persistent? Malicious content is stored on a web server. So this one is in the web browser, this one is in the server, in a database, file system, or any other object, later displayed to user in a web browser. Social engineering is not required. So this one does not require any social engineering. However, the reflected or non-persistent reflected require social engineering. DOM base would be malicious content from a user request is used by a client-side script write HTML to the uh, own page. Similar to reflected XSS, similar to this one. Malicious content from a user request displayed to the user web browser, also same. Social engineering is required. Social engineering is required. Run with the browser privilege inherited from the user in the browser. Run with the browser privilege inherited from the user in a browser. So nearly DOM base and reflected base are quite similar. Now reflected as XSS scenario. First, attacker will identify XSS flaw in application. It will go to a website and it will see that there's a flaw, there's an error or XSS error in this application. Second, send the URL the flaw to victim. Victim clicks on the URL, attack sent to application on behalf of the victim. Now, attack reflected back to the victim, attack execute. Okay, this is the victim, it will send it to here and it will again attack execute. Now, from the victim browser, send information to attacker. Now that the code that he put it here, if it will steal some data from the victim and it will send it back to him. Lab 1 reflected XSS scenario. From a browser address bar, Chrome, Firefox, JavaScript.alert, XSS test, JavaScript.alert document.cookie. Any data field that is returned is to client is potentially injectable. Script, alert, XSS test, script. Lab 2 reflected XSS scenario. So this one use a vulnerability on a search staff page on the CRAB URL container reflect the SSS attack. So this is the please log in, LarryHTG employee and the password. Log in as a user, for example, as a Larry with the password Larry. Click on the search staff button, okay, login. And then in the search staff button, you would search script alert dangerous script. Hit the find profile button and you are done. Verified in another employee using the link affected by the attack. Now, detect reflected XSS vulnerability. How to do it? Now, it would be test every entry point. If you have a search, user, password, or entering, for example, a cache ID or transaction ID or any search uh, input or any, let's say, input that you have, you need to test it. Submit random alphanumeric values. Check if a value is reflected in the response. You can use a burp intruder number payload. Determine the reflection context. Test the candidate payload. Send the request to burp feature. Modify the request to insert the candidate payload. Issue the request and review the response to see if the payload worked. Now we have a Portswagger support using a burp manually test for reflected XSS. It is the one of the labs, and Portswagger will give you a lot of good labs. However, this one also explain it how to do this. Block reflected XSS. Validate all input in the server side. Again, XSS can occur when unvalidated user input is used in a HTTP response. So if we prevented unvalidated user inputs, we somehow block the reflected XSS. In a reflected XSS attack, an attacker can craft URL with the attack script and post it to another website, email it, or otherwise get a victim to click on it. Now, persistent or stored XSS. Untrusted or unverified user input is stored on a target server. Lab 3 stored XSS scenario. Execute store cross-site scripting XSS attack. Login using the Bruce employee. Execute stored XSS attack against the street field on the edit profile page. Script language would be equal to JavaScript. Type would be text.javascript. And the alert or the pop-up message that it will be shown in here would be ha 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 script. Now this script, it will show me once I click on something, it will be ha ha ha. So normally I will be scared and I will think that I have been attacked or hacked. Verify that David is affected by the attack. Log in as a David with the David password and choose a Bruce from list and click on the view profile button. Now the fourth one, stored XSS scenario, we have the WebGoat. We are using WebGoat for this. Now we have a title, we have the message, and we have the submit. Now here's the message list. Okay, but instead of writing a simple message, we have put that script that you saw it here We've put it in the message side. When we submit and we click on, for example, let's say this DDD is the first one. We click on it and you would see that ha ha ha, or maybe you've hacked. Use the burp suite to detect the stored excesses. Follow the following link for testing. Now we have a port swagger. If we click on this one, it will show you exactly step by step how to do it. Block stored excesses. Scrub all input, especially those input that will be later used as a parameter to OS command script and the database queries. User should not be able to create the message content that could cause another user to load an undesirable page or undesirable content of that page when the user message is retrieved. Output encoding, HTML sanitizing, and safe syncs, sorry. So by another word, scrub all the input, make sure that if there's a user and password, make sure that no one can insert anything through it here. And output encoding, when you send the information to the server, make sure that the link would be encoded, HTML sanitization, and safe syncs. DOM-based cross-site scripting, also called client-side XSS, has some similar to reflected XSS as it has often delivered through the malicious URL that contain a damaging script. As we said, the DOM is also very related to, very similar to client-side XSS. DOM-based XSS, also known as a DOM XSS, arises when an application contains some client-side JavaScript that processes data from untrusted source in an unsafe way, usually by writing the data back to the DOM. The most common source for DOM XSS is the URL, which is typically accessed with the window or location object. More reading, portswagger.net, web security, cross-site scripting, DOM-based. Detecting and preventing XSS vulnerabilities. Application must, and must is a very heavy word. If you see it, it is a must and you should 100% do it. Must validate a data input to the web application from user browsers. Escaping user input, converting key character from a single character that aren't displayed into a string that the browser intercept and printable version of the character. Sanitizing user input, remove HTML markup, validating input and output encoding. Now we have cross-site request forgery. Cross-site request forgery. CSRF or XSRF is an attack that tricks victim into loading a page that contains image link like the one below. For example, we have an image source, mybank.com, send funds.due, ASAN, and this number. A malicious that initiate a get or post request that when receive an application cause some kind of transaction or server-side state change behalf of the user. So it will send this, the attacker will send me this link, and when I click on this link, some on my account, some funds would be sent to another account. No mechanism that allow a web server to distinguish between HTTP requests that originated from the user action. Now, there's the scenario. Consider that the user visited the malicious website, say hackerhome.org, get a freestuff.html containing the following code. As you see, hidden frame, my service updated profile, input hidden name, password, and hidden frame display none. Due to the same origin policy, this page does not have access to the my www.service.com update profile cookie. The browser executes the JavaScript specific in the script tag. When the browser makes the HTTP post request, it sends along with the cookie it currently holds for the domain of a requested URL. The password of the legitimate website is changed by the malicious website. Left 5 cross-site request forgery. In a web GOAT, select cross-site request forgery from the left menu. HTTP 127.0.0.1.80.80 web GOAT attack screen 24 menu 900 and number 51. Type the following in the input boxes and click submit. In the title, type test. In the message, hi, image source, and so on. Use a burp suite to intercept the rendered forged URL, request. Now, We know what the XS forgery RF is, but what are the impact on a web application? XRF is a concern with any web application that keeps server-side state or executes server-side transaction on behalf of its user. It will update information or profile information, enable user to send message or post message, financial or e-commerce transaction on behalf of the users, stored any kind of data on behalf of a user. Now we have cross-site script inclusion, XSSI. In this type, the script tag specifically allow the inclusion of a script from other domain enabled to sharing of a code. Cross-site script inclusion vulnerability allows sensitive data leakage across origin or cross-domain boundaries, which is very dangerous. XSI is a client uh, side attack similar to cross-site request forgery, but has a different purpose. So XSI is very similar to CSRF, but it has a different purpose. XSI instead uses JavaScript on the client side to leak sensitive data from authenticated sessions. Cross-domain inclusion of a static script. Preventing XSI would be authentication via action token, restriction to post request, preventing resource access for a cause reason. Interaction of a document from a different origin. The same origin policy prevents script in a page loaded from. However, there are several other forms of interaction that are not restricted by the security policy enforced by the browser. An attacker originate a request to ban a website from a malicious website. According to the same origin policy, the request is originated from a malicious website enclosing the page. Example, if we did it manual, script source, mywc7.com, same URL, or automatically it would be this. HTTP request authentication. HTTP by itself is a stateless protocol by itself. However, the HTTP authentication would be authentication credentials are supplied into HTTP header. Cookie authentication. The application requests the user authentication credential in an HTML form, then the application issues session token in the browser as an HTTP cookie. The browser automatically returns the cookie with each subsequent request to the server. Hidden from authentication, a less commonly used in a variant of the aforementioned schemes. HTTP authentication credentials are cached in a memory or stored in a disk. HTTP authentication versus cookie-based authentication. Which is better, HTTP authentication or cookie-based? It would be a discussion for you, Miss. And if you do understand the difference and which one is better, we can discuss it again. Input validation versus output sanitization. Now, input validation versus output sanitization or HTML and HTML escaping. Table 10 character escape from a JavaScript literals. Character these would be the escape would be dash T, tab, line feed, dash R carriage return, and the next line, and so on. Maximum set of character be escaped by HTML escape function would be this AMP, LT, and GT and GWT, and so on. Now, assignment 3 would be cross-site scripting attack protection. Now you would have your an assignment, write one-page research summary of the current state of the art techniques of detecting the preventing cross-site scripting attack. 2 pages, 10 references, and a group of only yourself. And of course, if you read these two links, you will have your 2 page in no time. Our next session would be session management, or maybe we will have the buffer overflow. And if you have any question, you may ask or send me an email. Thank you very much.